So today I want to talk about this little Sony LCD TV. It's a little 26-inch. It's a model KDL-32L5000. And the problem that we're having with this one today is it was brought in for no remote operation. The set works perfectly normal other than the remote control does not work. And luckily I have a schematic here for this little circuit board, and it's the remote receiver circuit board. And so just a real quick rundown of what this is. This is actually the remote receiver over here, and I don't know if you can make it out. Hopefully you can on the video. But it's got two pins for ground. Pin 1 and pin 2 are both ground. Pin 3 is the VCC power supply, and on that one we should see 3.3 volt standby. And pin 4 is the signal output of the remote receiver. And if you follow it through here, there's a pull-up resistor, which is a 10K, 10,000 ohm resistor. And then there's a little 10 ohm isolation resistor. And then there's some capacitors to ground to get rid of noise on the line, some little EFI, RFI filtering. And then it goes to pin 2 of this connector, which is CN9100. So what we're really interested in is looking at the voltages on pin 2 and pin 3 and find out, do we have our 3.3 volts over here to the remote receiver, and do we have the video or the infrared output signal going back to the microprocessor. So let's hook up the meter and take a look. Okay, so I've got my negative lead of my voltmeter just with my little clip lead into a ground RCA input. Those are always very good chassis grounds. There's my negative lead just clipped onto it. And so let's take a look over here. First thing I'm going to do is, according to the schematic, pin 1 of this connector should be ground. So I'm just going to take my ohm meter, it's in the ohm position, and I just want to make sure I see close to 0 ohms. And I do. Pin 1 is ground, so I'm going to put this back on volts now. Let's go ahead and turn this unit back on, get my schematic handy. Pin 2 is the infrared detect pin, so I should see 3.3 volts on that under normal operation, and I do. And pin 3 should be the 3.3 volt standby. I have that there as well, 3.3. So let's get a remote control, and as I hit the button I get no response whatsoever. The TV does not respond. So what I'm going to do is I'm going to put my probe on pin 2 here, and I see no change as I'm pressing the power button on my Sony remote control. So let's flip this board over and see if we can actually find out, is the signal making it to the remote receiver, or is it stopping along the way? Very hard to see, but this is a very small remote receiver right here, and these two pins are connected to the metal case. So these are pins 1 and 2, and then these are pins 3 and 4 down here. And so I'm not sure the pin out exactly whether this is 3 or 4, but one of them has 3.195, a little bit low. The other one only has 0.307 volts coming out of it. That is a very big problem, because according to the schematic diagram over here, it should be virtually a straight connection from right over here through a coil, through a resistor. There's another resistor, another resistor. These are on separate lines, of course. And we should see 3.3 volts on both pins 3 and pin 4, but we're not seeing it. So let's try to find one of these capacitors. Let's try to find C9113 or 9114 here and see if I can find out what's going on there. Okay, well, these two capacitors right here are 9113 and 9114, and they're pulling the voltage way down, 0.3 of a volt on both of those. And according to the schematic, that is the VCC line, pin 3. That's the power supply to the infrared receiver. And so we've got two 22 ohm resistors in series and a coil, an inductor, and that's just used to remove any spurious emissions that might be on that line, any noise. So let's take a look and find out where we might be losing our signal. Let's see if we can find C9105, 9107, and 9108. Here's C9105. It has 1.8 volts on it, which is close to half of 3.3. And this 9108, all three of these are in between two 22 ohm resistors. So if you were to pull this voltage down to effectively ground, you should see about half of 3.3 here. So I would have to say we either have a bad remote receiver chip or we have a shorted capacitor. So I've got the power off to the TV right now, so I just want to do an ohm meter check from these capacitors to ground, and we'll see what we end up with here. A 2.8 ohms, definitely too low for operation. Let's take a look at these. Yeah, about 25 ohms on those. So one of these two capacitors is probably shorted, or there's a possibility that that little remote control receiver could be bad as well. One thing I noticed is it does feel warm over here. And so if there is voltage flowing across these 22 ohm resistors, they will produce a little bit of heat. And I'm just wondering if the capacitors might produce a little bit of heat and lead me to which one is defective. So I'm going to do the trick that I got from Dave's TV up there in Oregon. And I'm going to freeze these little capacitors and turn the set's power on and see if one of them thaws out faster than the other one. So I'm just using my can of air. I've got it upside down here so the refrigerant comes out. I'm just going to freeze all this really good. Wait for the frost to form. Alright, there it is, frosty, so I'm going to go ahead and turn the set on. I can see right away this small little surface mount resistor is already defrosted. It does look like the lower capacitor defrosted quicker than the upper one did. Let's go ahead and strip it off the board and see what happens. Alright, so I'm just going to try to very carefully heat both sides of this capacitor to the point where it's molten. And hopefully it will just slide right off the circuit board. I may have to add some fresh solder to it. There we go. If I can get that other end. So it's completely off the board. Hopefully you can still see it in the camera. And it reads 3.1 ohms, kind of hard to see on the meter. 2.8 ohms. Let's see. So if I check where the capacitor was, 1.7 million ohms, now 1.7 meg ohms. So I'd have to say that capacitor is bad. So looking at the schematic for this circuit, you can see that these capacitors are 10 microfarads at 10 volts, and they're ceramic capacitors. They do a very good job of filtering radio frequency emissions and EFI, RFI on this line. But they're ceramic, and a 10 volt ceramic capacitor, especially 10 microfarads, it's doing a lot. So I'm going to go ahead and replace these with electrolytic capacitors. I have some little surface mount 10 microfarad capacitors that'll go in there very nicely. But instead of having 10, 20, 30, 40, 50, and finally one more way over here, 60 microfarads. Now, this one is a 100 picofarad capacitor, and this one is a 100 picofarad capacitor, which is on the output line of the infrared receiver. So I'm just going to go ahead and take these two out, replace them with one 10 microfarad electrolytic. I'm going to take those three out, replace them with one 10 microfarad, as well as taking these two out and replacing them with one 10 microfarad. I'm sorry, I'm going to leave the 100 picofarad because it's rated at 50 volts. I'm just going to take the 1 out and replace it with the 10 microfarad capacitor. So let's go ahead and do that, and we'll see where we get. Now pay particular attention if you are using electrolytics to the polarity when they go back in. The ceramic capacitors are not polarized, but the electrolytic capacitors are, so you need to pay very particular attention to the direction they go back in. Okay, so here's my board. I've got the capacitors stripped off there. You can see the pads where they were. 1, 2, 3, 4, 5, and 6 capacitors taken off the board. So here are the old little surface mount capacitors that I've stripped off the board. And what I'm going to use here is I've got some it's hard to read the numbers, but they're 10 microfarad, 16 volt surface mount chip capacitors. And so all I'm going to do is I'm just going to fold the leads back till they're straight. And I'm going to pull them off and make them into just leaded electrolytic capacitors. And now if you look at the pin sizing, it's almost perfect to place on that circuit board. Just once again, pay particular attention. The negative side is the side with the black on it. Okay, I've got my capacitors replaced on the board here. And the polarity of them, you can see that this one, it may be hard to see on the camera, but this one, the negative is toward this side of the board. On these two, the negative is towards this side. And to verify this, once your board is hooked up and you've got your ohm meter in the ohm position, if you simply put your probe on the negative lead, you should see very close to 0 ohms. And just to double check that, I'll put the probe on the positive lead, and we should see much higher resistance, which we do. So let's go ahead and turn the set on now. And let's go ahead and get to volts. And we'll go ahead and take a look at the positive side on these, and we should be seeing about 3.3 volts. And we are, which is very good. That's exactly what we want to see. Let's go ahead and turn this back over. We'll check these pins that we had problems with before. 3.3, 3.3. Now you can, on these sets, you can go ahead and put your voltmeter on the remote sensor pin. And as you press any of the buttons, you can see the voltmeter does change. That's because it is establishing a pulse on that pin going to the microprocessor. So let's go ahead and just hit the power button now. And I heard a relay click, so I know that it's working. And so that definitely takes care of those problems. Let's go ahead and get you some quick voltages on the set when this set is in the standby and in the run position real fast. And that way, if you're ever doing some troubleshooting, you know exactly what to look for. Okay, so here's some voltages on the main connector from the power supply board. Pin 1 is the power on command, and we only see that in use when it goes to turn the set on. Pin 2 is labeled AC detect, and its job is to tell the main board from the power supply if the AC power is good or not. And so if I switch the AC power off really quick, you can see that goes down to 0 instantly. Even before the relay clicks, it goes to 0. Now pin 3 is the standby 3.3 volts. And once again, I'll switch the power off. And you can see it stays up for a second. So the set would not know, unless it had that AC detect, that the power was good or not. Now all these pins are unregulated 12 volts. And we should see close to 0. It did pulse for a second, which is why the voltage is falling. And we've got ground. And then we should have regulated 12 volts over here. And once again, that's only going to be active when the set is actually running. And so these pins here are from the keypad. So we should have 2 key scan lines. Hopefully you can see it with my hand in the way here. That pin is ground, and then we should have voltages on pin 3 and pin 4. And as we press buttons over here on the keypad, we should see those voltages change ever so slightly. And we do. So it looks like this one is only used for the power pin. So pin 4 is the power pin, so when you press that button you should see that go to 0 and back up. And pin 3 is every other line in a resistance ladder setup. So every button that you press, I'm pressing different buttons now, you'll end up seeing a different voltage. And based on what that voltage is, the microprocessor knows which button you've pressed. So now let's go ahead and turn the set on while checking the voltages on the power supply connector. Once again, pin 1 is the power supply on line. So when I press the button, you hear the click, it goes up high, 2.7 volts. That turns on the relay on the power supply. Pin 2 is still AC power fail. Pin 3 is standby 3.3 volts. Now we should see our unregulated 12 volt line, which is actually closer. Oh, I'm sorry, it is labeled 15 volts. Unregulated 15 volts. So we got 16, just over 16.5 volts on that line. We've got ground, ground, ground. And now we should start seeing our 12 volts. 12 volt run, 12.06. And now let's take a look at this other connector. This is to the inverter board. So this is what controls the backlight inverter. I can get on these little pins here. So on, looks like pin 3, we've got 3 volts. Pin 2, 3.3 volts. And pin 1 is ground. So I'm not sure the configuration of these two pins, but one pin is going to be the backlight on and off command, and the other is going to be the pulse width modulation dimming command to dim the inverter. Now I'm over here on the inverter side from the power supply to the inverter board, and all I want to make sure is that I have my ground and that I have 24 volts when the set is on. Okay, so I see 25 volts when the set is on. As the inverter kicks on, it may actually pull down just a little bit. There we go, 24.7. And so it looks like the first 4 pins are all 24 volts, and then the last 4 pins are ground. So if you're having a problem with your backlight, measure the voltages that I just did from the main board on that 3-pin connector. Make sure you have your backlight on command and your dimming command. And I'm sorry, I don't know the configuration of which one is on and which one is dimming. And then make sure you have your 24 volts that goes to the inverter board, which is under this plastic cover right here. So let's take a really quick look at some of these power supply regulators over here. There's a couple of them over here in this corner. And I thought we'd look. Now the set's in the standby mode. I just wanted to see if we had any voltage on these pins whatsoever. And it looks like we do not. And there are also two of these little 3-pin regulators over here. Let's look and see if we have anything in the standby mode on these guys. Rarely do we ever have problems with the Sony boards. They're not like the Vizio boards where we have those little, they're called low dropout regulators, fail. Rarely do we ever see failures like these on the Sony boards. So let's take a quick look while the set's on of what we should see over here on these little regulator ICs. 6.6 volts, 5.1, 9.3, and 12.05 on that one. This one's got 5.1. Let's look at these little regulators here. We have ground on that pin, 1.2 volts, 3.3. Ground on that one as well, 3.3 volts, and 5.1. There's one more over here. I don't know if you can see it in the video. Hopefully you can. Ground, 5 volts. And 9 volts on the input. There's one just past the tuner. 7.8, 9.1, and 12 volts. Okay, so here's our set. Let's. I've got my remote in my hand here. Hit the power button. It definitely comes on. The remote receiver is working. The power LED lights up. And there it is. It's working just fine here. Let's go ahead and get into service mode real quick. So, power off. Wait for the click. you want to press display, the number 5, volume minus, and power. And that's going to bring it up in the error display. So over here it's in the self-check, and we can see all the errors that it lists here are 0, which is a good thing. Here's our hour counter, 3,541. Don't know if you can see that in the video or not. And so let's bring it up in the actual service mode. Power off. Same code, just a little different. Display, the number 5, volume plus, and power on. And you can see we have a lot of other options on this one that we can do. Sound adjust, wideband tuning, range scan, self-diagnostic history, status information. Probably the self-diagnostic was the one I was just at. Yes, it was. But that's a direct entry mode to get there. There's all sorts of other adjustments. I don't recommend changing those unless you know exactly what you are doing. You can change the equalizer here if you want to play with the sound settings, the bass and treble offsets. There are several different modes that have all sorts of different options here. You can set your range of what channels you want to scan when you're doing your auto program. Status information talks about the firmware version. I don't recommend messing with any of these unless you know exactly what you're doing. Well, we saved another one from the trash or the recycle bin, as the case may be. Thanks for watching. I appreciate your views and your comments, although things have slowed down for me, so I do have another job, so this is only a part-time job now doing electronics repairs. I appreciate your comments, your views, and your support. Once again, you can follow me on Twitter at NorCal715. Everybody have a great day. Hopefully, with your help, we can keep these out of the landfill and out of the recycle bin. Have a great day. Bye-bye.